Okay, so today's lesson is on compound linear inequality notes. We're going to be dealing with two different sets of inequalities, ones that involve the word and the other ones that involve the word or. The ones that involve the word and, I'm going to go ahead and highlight those in pink. The ones that involve the word or, we're going to highlight those in green. Or are a little bit easier to work with, so we're going to handle those first. So when we have or, it's an inequality that's combined with the word or is usually worked out in two separate inequalities, and we kind of graph them in the same number line. So what I mean by that is take a look at this one. This one has the word or, and on that we're going to treat these as two separate inequalities. This one and this one. Let's go ahead and start off with the first one. I'm going to go ahead and tackle that one by subtracting 3 on each side. I get 4x is less than 8, and divide both sides by 4. I get x is less than 2. So we're done with the first part, but again, the word or means we got two different sets going on. So let's go ahead and look at the next one. I'm going to go ahead and add 4 to both sides. Now 3x is greater than 12. Divide both sides by 3. X is greater than 4. And I have the word or in between. So on the number line, I'm going to go ahead and graph the first one, which is x is less than 2. So I graph it like I normally would. I'm not going to shade it because there is no equal sign. And since it's less than, I want the numbers that go on the left. And then the ones for x greater than 4, same thing. I'm going to circle the 4, and because it's greater than, I'm going to go to the right. The word or allows for two sets to be unified together. So all my answers for this one work. All of these numbers work. Notice that 2 does not work because it's not shaded in. 3 does not work since it's not shaded in. 4 does not work but because it's not shaded in. But 5 does work because it belongs to this set. It doesn't matter if you belong to the first or second. As long as you belong to one of the sets, you're going to be part of the solution set. So or basically means put two sets together. You're going to have a lot of options as far as your answers are concerned. Let's try it again. I'm going to go ahead and I have the word or. So it means as long as you're part of this set or this set, it's going to be fine. So I'm going to go ahead and start by subtracting 1 on each side. And divide both sides by 3. Again, x is less than 1. If I did the same thing, I'm going to go ahead and write the word or in between. If I did the same thing on the other side, I'm just going to solve by adding 5 to each side and dividing both sides by 2. I get x is greater than 6. Now I like the way that's written because I have my smaller set on the left, my larger set on the right. And now I'm just going to go ahead and graph both sets. So I need x's to be less than 1. Circle the 1 and go to the left since it's not shaded. And there's no equal sign on the 6, so I'm going to circle the 6, again, not shaded. So my solution set becomes all the numbers that are graphed and shaded there, which is quite a bit, except for the numbers between 1 and 6. Those numbers do not work. For the word and, it's a little bit different. When an inequality is combined with the word and, a compound inequality is formed. However, we usually write this in compact form, which means in one set. I just want you to understand that there's still two sets going on. It's just we're combining them so that it looks like one. So if you look at that first one, it looks like it's only one inequality, but remember we have an inequality here and here. So it's actually two inequalities being pressed together. So I need x's to be doing something, two different sets of information, which we'll show you in a little bit. So I said that there's two inequalities, which means there are three sides. There's the left side, the middle side, and the right side now. So we're going to go ahead and solve for x, but this time, like in order for me to undo that minus 8, I need to add 8. But again, there's three sides, so I'm going to add 8 to all three sides. I'm going to add 8 to the left, to the middle, and to the right. So negative 2 plus 8, that's going to give me 6. I'm going to drop down the inequality. These are going to cancel. I'm left with the 3x. I'm going to drop the inequality, and I'm left with an 18. X is almost by itself. We're just going to undo the multiply by 3. So I'm going to divide everything by 3. 6 divided by 3, I get 2, less than or equal to. These are going to cancel each other out. That's an x. And then 18 divided by 3, that's going to give me 6. So again, I want you to think of this as a double inequality. I need x to be bigger than bigger than or equal to the 2, but I also need it to be less than or equal to 6. So the way you graph this is you just circle the boundary points. It's 2 and 6. Because they're shaded in, because there's an equal sign, they need to be shaded in. And notice that here my x is stuck between the 2 and the 6. So we're going to shade. These are all the x's that I can pick. My x's are stuck between 2 and 6. Notice the difference between the two. When we had the or, we had all these answers to the left and all these answers to the right. We had the word and, we had them stuck between these two numbers. And it was much more restrictive, right? It had to be less than 6, less than or equal to 6, and it also had to be bigger than or equal to 2. So there's two different things that you had to satisfy at the same time, which is why we didn't end up with a lot of answers at all. All right, hopefully that made sense. Let's go ahead and do the next one. We're just going to go ahead and undo the stuff that's being done to x. So on all three sides, I'm going to go ahead and subtract 6. These are going to cancel. I'm going to be left with 2 is less than or equal to 2x is less than or equal to 12. And then to get rid of the times 2, I'm going to divide everything by 2. So on all three sides, it's going to get divided by 2. 2 divided by 2 is 1 less than or equal to. These are going to cancel. I get x less than or equal to 6. So again, we're going to circle the boundary points. I'm going to circle the 1. And I'm going to circle the 6. Because they have an equal sign, they're going to be shaded in. And because my x's are stuck in between those two boundary points, I'm going to go ahead and shade in the middle. All right, so that takes care of the first page. We're going to move on to the back. I told you that this was two inequalities kind of stuck in one. And on the back side, it's the exact same thing. So it says, right there, writing in compact form, there are times when the function does have the word and between the inequalities, and you have to write them in compact form. It's so much easier to understand the inequality when it's in compact form. So if they use the word and, we generally try to switch it to compact form. We're going to be using this as a hard rule. We want the least number on the left and the greater number on the right. If it's not written in that form, we're going to make it so that it's in that form. So it says directions. Below are the solutions, and we need to write them in compact form. So here I have something that says I need to have x to be greater than 3, and I need x to be less than 6. I want both of those to be true at the same time. Now I'm going to try to rewrite these and statements so that they look like these and statements over here. Notice when they do that, they stick the smaller number in the front, they stick this larger number in the back, and then they have the x stuck in between. So we're going to try to do that. I do see that the smaller number is in the front, so that's good, except we want to completely reverse this statement so that the number is all the way in the front. So we're going to reverse it. That means instead of x is greater than 3, I'm going to write 3 is less than x. And because it has the word and, I can actually put these two inequalities into the same inequality. So 3 is less than x is the same thing as saying x is greater than 3. And the next thing I want to write is x is less than 6. Well, this is already saying x. I just need to write is less than 6. And that's it. These two statements here are the exact same thing as this one statement down here. 3 is less than x is less than 6. So not only do we need x to be on the bigger side of 3, that's this. We also need x to be on the smaller side of 6, that's this right here. This is pretty easy once you get the hang of it. You just got to make sure that the smaller number is on the left-hand side, and if it's not, you're going to rearrange the order so that it is. So here I have x is greater than or equal to -2, and x is less than or equal to 1. So let me go ahead and reverse this statement just so I can get the -2 in the front. -2, instead of greater than or equal to, I'm going to change it to less than or equal to x, so that takes care of the first one. And now I'm just going to sneak this second part next to it, so it says less than or equal to 1. Okay, this one I don't like as much because the smaller number is on the right. So I'm going to take this statement. This is the one I'm going to reverse. And we're going to start with that statement first. So when I say x is greater than or equal to 0, I'm going to rewrite that so that it says 0 is less than or equal to x. And then I'm just going to go ahead and sneak the rest of this part because I already have the x part. And I just need to write is less than or equal to 3. On the next one, they do have the smaller x over here. Remember, -6 is smaller than -2. I just need to reverse this so that the -6 is in the front. I'm going to write -6 is less than or equal to x is less than -2. Notice that this one does have an equal sign on the first part, but this one does not. And again, I'm just using the statements that they're giving me right there. Okay, this is x is less than or equal to 4, and this is x greater than 2. I want this one first. We're going to reverse it so that the 2 is in the front. So I'm going to write 2 is less than x, and x is less than or equal to 4. And we got one more. This smaller number is over here, so I'm going to reverse this one. Instead of x is greater than -4, I'm going to write -4 is less than x. And then I'm just going to add the second part to it, is less than or equal to 0. And I forgot to highlight all the word ands that we have here. The only reason I'm able to combine those is because I'm using the word and. Okay, if they would use the word or, we're going to treat them as two separate inequalities and work with each one independently. Okay, now that we have all of this, we're going to stick all of this that we just learned. We're going to combine them all together. We're going to practice these 4 problems, and then we should be good to go. So let's take a look at the first one. The first thing I notice is it's a double inequality, so that means this must be using the word and. All right, I'm just going to solve it using the 3 sides. So right now that x over 2, I get to subtract 1 from all 3 sides. -3 minus 1, that's a -4, is less than or equal to. These are going to cancel. I'm left with x over 2 is less than 1. What's being done to the x right now? It's being multiplied by 2. So I'm sorry, it's being divided by 2. So I'm going to multiply all 3 sides by 2. 2 times -4, that gives me a -8 is less than or equal to x is less than or equal to 2. As far as graphing it, I just made a mistake. I didn't mean to do that. Hopefully you caught that. For some reason, I put an equal sign down there when it doesn't belong. All right, let's try that again. Let me go ahead and graph this. Because it's one double inequality, I can just go ahead and circle the boundary points. I'm going to shade the -8 because it has an equal sign underneath. And my x's are stuck between those two those boundary points, so I'm just going to go ahead and shade the middle. For problem number 2, this time they're using the word or. So I'm going to treat these as 2 separate inequalities and just solve each one separately. So right now I'm going to get rid of that -5. I add 5 to both sides. 7x is greater than or equal to 70. I'm going to divide both sides by 7. X is greater than or equal to 10. Or, on the other side, I'm going to get rid of the minus 2 by adding 2. Negative 3x is greater than or equal to, that's 0. Right now it's being multiplied by negative 3, so we're going to divide both sides by negative 3. And here, you have to be careful. Because I'm dividing by a negative number, that inequality symbol needs to switch like that. So this technically should be my answer. The only thing I don't like about this answer is they have the smaller inequality on the right. So let me just crisscross these things and let me write them like this. I'm going to write x is less than or equal to 0 or x is greater than or equal to 10. So on my number line, because I'm using the word or, I'm pretty sure I'm going to have two different sets. X is less than or equal to 0. I have the 0 right here. I'm going to go ahead and shade it. And I want my x's to be less than or equal to 0, so we're going to go to the left. X is greater than or equal to 10. I'm going to circle the 10. I'm going to shade it. And I want the numbers to be greater than or equal to, so I'm going to shade it to the right. And then over here, I have negative 1 plus 5x is greater than negative 26. And, so that word and is going to make it so that I'm going to try to combine these two later. But first, let me just treat them separately. I'm going to add 1 to both sides. That gives me 5x is greater than negative 25. I'm going to divide both sides by 5. This time, because I'm dividing by a positive 5, we do not switch the inequality. X is greater than negative 5. And I'm going to go ahead and solve this one. I'm going to add 2 to both sides. 7x is less than or equal to 14. Divide both sides by 7. X is less than or equal to 2. Now this has the word and. If it has the word and, you're going to try to combine it into one inequality like we did over here. Okay? So we treated it like the word or, but now I want my smaller inequality on the left. I have it, but I want that number to be on the left. So let me go ahead and reverse this. And when I reverse it, it becomes negative 5 is less than x. I'm going to stick the less than or equal to 2 attached to the very end, and this is what I'm going to be graphing. So I'm going to start at negative 5. I'm going to circle it. I'm going to end at 2. I'm going to circle it. Because the 2 has an equal sign, I'm going to shade it. And notice that my x's are stuck between the negative 5 and the 2, so I'm going to go ahead and shade it in the middle. Last one has the word or. I'm going to go ahead and add 1 to both sides. We got negative 10x is less than 0. Divide both sides by negative 10, but since I'm dividing by a negative, I need to switch that sign. So I get x is greater than 0. Or I'm going to get rid of the 10 by subtracting 10 on each side. 3x is less than or equal to negative 15. Divide both sides by 3. X is less than or equal to negative 5. This would normally be my answer, but I don't like it since the smaller inequality is on the right. So let me just kind of write these in a different order. X is less than or equal to negative 5, or x is greater than 0. When I graph these, I have the negative 5 here, and I'm going to graph x is less than or equal to negative 5. That's this way. Or x is greater than or, I forgot to shade this. This needs to be shaded. And then the other one says x is greater than 0, so I circle the 0, and I just go to the right. Okay, those are all the notes for today. As always, if you have any questions, please feel free to ask.